Hello physicists and mathematicians. Today I will launch a very new series for the physics for beginners. So this course is intended for all the beginners who want to learn physics for their academic career or anything else, for meme, anything else. So let's start. Before jumping into the course, I want to introduce myself. This is Indrajit Banerjee and I am a PhD scholar and I love physics, and also I love mathematics. So if you are really new to my YouTube channel, I will launch more videos on very interesting topic later. Okay, so what is physics? So if you really don't know what is physics, so here is a very quick summary I have recollected from my memory. So suppose if you have a ball or anything else in your hand, and if you throw in something in somewhere else, so what will happen? We know from our experience that if we throw a ball into the air and it will go like this, right? So from here the ball will go and from like this. So we can measure the projectile or path of this ball. So we can make few equations to make that it so we can be very sure that where it will land. So physics is fundamental of science. It's very so there's a lot of people are arguing with mathematics and physics, but I don't personally, because I think mathematics is language for science, where physics is fundamental of all sciences. So if you have ever dreamed some very consecutive galaxies in your head to the ultimate smallest scale atoms, so you can imagine physics as the ultimate or microscopic world to macroscopic galactic world. So here is the domain of physics. You can go from the smallest to the largest scale. So that is how physics defines. So I always prefer my students that just don't memorize the definition of physics. It's very uninteresting topic if you just memorize everything in physics or science specifically. So just go through it and just learn by example from your natural life or any experience if you are constantly having with some daily lives. Okay, so first we will make sure that you know some physical properties of physics. Like first thing first, we have to mention that there is three basic physical quantity we have to measure all the time. So one is mass, another one is length, another one is time. So these are fundamental and three basic quantities we have to learn more, but for now it's only three properties. Okay, so and what is that? Mass, length and time. We can define mass for mass, which is defined by the dimension m. I will cover this in this video, but later. So here it is length. So length is L, and time, what is time? I will cover that again. Okay, so you can see what I am currently writing over there is that, so mass, so m for mass, L for length and T for time, and in the third parenthesis we have mentioned that this is nothing but dimensions. Okay, so first thing first, if you really want to make sure that you know physics fundamental thing of the physics or theory, then you have to go with first thing, that is length or distance. So we measure distance, right? So distance is simply length. You can measure length with scale. So what is a scale? Why we have a 1 foot scale or 30 inchy or 12 inch scale or any type of scale you have, or 1 meter scale also? So what is that? Actually we compare with the predefined scale with a object so that we can measure. So measurement is a process of comparing with the predefined thing to the object that we did not measure yet. Okay, so that's how all the things go in the science. So measurement is very difficult thing. If you really want to understand that how this measurement is very difficult, I will talk you later, because physics is not the measuring only the length or time or mass, it's more than that. Okay, so I will go with more cities. So for now distance is nothing but length. So if you have ever traveled from your home to your school or your college, then obviously you have encountered with the term that your car driver always use, that is speed. Okay, so what is speed? So speed, it's very easy. It's nothing but the ratio of distance covered. It's a distance covered in a given time. So distance divided by time, which gives the speed, right? So here it's speed equals to distance or time. So we can say, if we can take the measurement of dimensions, so obviously distance for length we will take like this and then t. So this is how we can represent L or T, L divided by T, right? Okay, so now we have covered the distance and time. Now what about the velocity? So velocity is similar to speed, but there is a catch. So velocity in physics, velocity is not equals to speed, because speed is it's like distance. So speed is measurement of distance divided by time, where velocity is the displacement. It's actually displacement divided by time. So what is displacement and what is the distance? So here we are taking an example from our daily life. So suppose you are traveling with your car to another city, right? So and then from here you are just moving from here, and then you are just traveling here, and then again in night you just return here. So if we take a whole process in one single process, like back and forth, then it's called displacement. So that's how we can call displacement is not actually distance, rather the point of beginning and point of end. So if we take an example like this, here we are moving to, so this is the point A and this is the point B. and again we are taking from here. So obviously distance is the curved line where displacement is simply the straight line joining the A and B. And also if we move from A to B and again B to A, so total displacement will be 0. So here is a very different and difference between displacement and distance. Okay, so velocity is displacement divided by time, so that's also has the same unit, that's L divided by t, which is stands for time. Okay, so let's jump into other sections for quick. So what is accelerations? So now we'll cover. So suppose you know that a car has accelerator, right? Or if you are sitting in a train and you see the train speed is constantly increasing over time. So what is that? It's simply called accelerations. So acceleration is something that when velocity is changing over time, but acceleration means for positive change, like velocity is increasing, and there is another term for velocity decreasing for retardations. Okay, so we will call accelerations, which is acceleration for velocity when velocity increases over time, and retardations so retardation means velocity is decreasing over time. Okay, so that's how define acceleration and retardations. And the formula for acceleration and retardations is very simple, but we will derive it few minutes later. Okay, so now we will jump into a very quick overview of mathematical representation of velocity, speed, and everything here we have covered. Okay, so here you can see that velocity, which is v is represented as velocity, and also for speed, so we are considering here velocity, so v equals to d by t, right? Now we can define, there is another part is called accelerations, which can be represented by a, it's small a, and small a means it's simply we can call this is v minus u divided by t. Now what is that? So here v represented the velocity, d for displacement, and t for time, but here a for accelerations, v, so this v is the final velocity. So here the v means the final, and u, here u represent, that means initial. Okay, so what does it mean? And t for time, obviously. So what does it mean? So simply we are calculating over here that v and minus u, which means the change in velocity, that is final minus initial velocity over time, so that we can get what is accelerations. And if the result is positive, it's called accelerations. If the result is negative, and then it's called retardations. That's it. So that is how we can represent a equals to v minus u over t. So that's it. It's, and also this representations is accommodate in globally, so that actually I am using the global terms. You can use your own terms so that you can play with it. It's your choice, but I prefer the global markdowns. So now here we have covered the mathematical aspect of velocity and accelerations and retardations also. Now what about the force, and what about the work done and energy? So here is a very good examples. So there is also a term called force, right? And it is represented by F. Okay, so velocity, accelerations, and then force. So what is force? So here is a very good example I always teach my students. If you have pushed something, so here is my duster, okay, so I am pushing there, so this is the push I am pushing, okay. So this is called force. I am acting on a body, and also I can pull it from somewhere else. So suppose there is a string attached to this duster to from these locations, okay, so I can stretch it down so that I can pull it. So that's the force I am applying on this object to pull. So the power of pulling or the pushing is called actually force, okay. So definition is not important to me, but you have to understand the real examples. So that's how force is defined. So force is nothing but it's simply called push and pull, okay. So now every push and pull does not have, so there is a lot of terms you can learn about, like non-contact force or contact force. So contact force means there is a point where two objects are contact, there is a contact point, okay, right. So I am pushing you, so and also you are pushing me, so there is a contact point, right. But somewhere there is some example I will give you later, that's also have no point of contact, but they are pushing or pulling, okay. So that's how it goes. So here it's a example of force, that's F, okay. So what is the relation between force and accelerations, okay. So force and acceleration has a very intuitive mathematical formula or link. It's called F equals to mass times accelerations, okay. So it's called force equals to mass time accelerations. I hope you can see it. So force equals to m times accelerations. So that means if you are pushing someone, okay, so if you are really pushing someone hard, okay, and the object has a mass of 1 kg and you are pushing this 1 kg and the object has started rolling or moving with the acceleration of 1 meter per second square. I will go with the unit later, but for now just think about that. I am pushing something and the body or the object starts to move, okay. So velocity is changing, so there is accelerations. And also if we pull something, or suppose an object is coming, like any car or any bicycle is coming towards you and you just hold it, so the bicycle speed from 5 km per hour to just reduce to 0 km per hour, so obviously there is a retardation. So force is that, so mass times accelerations or retardations, that's how we can get force mathematically in physics. So that's how force calculated. And then there is another term that is called work. So work or energy done, okay. So I will represent W or E, okay. So what is W or E? So W is work done and E for energy. So simply, if you lost your energy to do some work, so basically energy and work is same, and it's really same. So if you work hard, you lost your energy, right? So the amount of energy you are losing is equal to the amount of work done you have done. Simply, it's really as simple as that. So now we can say, so this is W for work done, E for energy. We can say it's simply mathematically force multiplied by distance. So here you can see this force and distance. What is this force and distance? So if you are working on something, that means you are applying a force on any point of object, right? So that means you are pushing or pulling, and you are applying a force. Now for that reason, there will be a distance the object will cover. Or suppose an object is about to move about 5 meters, but you, for your force, the object stops immediately. So 5 meters is the distance for retardation case. So that's how you can calculate W, or work done or energy, equals to force multiplied by distance, or force time distance. Okay, so that's how everything you need to know as a beginner for physics. Now we will conduct something that I have said that I will give example for later. So here is something. So basically this project is intended for schoolboys who want to learn some physics beginning course at very quick pace. So I am giving a very quick, okay, so I am not elaborate it something like a lot of examples and lot of exercise. So here is, I am just teaching you the basic and fundamental parts. Now we have to cover the unit. Okay, so what is unit? And this is a most important part in physics and also mathematics. So unit is nothing but kg meter second. So think about that. So when you weight yourself, you get the result like 50 kg or 100 kg or 0 kg. In kg, normally you get the result in kg, right? So if I talk, if I say that your weight is 50, so what that doesn't mean? It simply means nothing, because it has the value until it gets the unit. It doesn't mean anything, right? So you have to mention the unit. Even a single change in unit can destroy your value, because 50 gram and 50 kg is very different. Okay, so actually 1 kg equals to 1000 grams, so obviously 1000 times less for 50 gram. So you can talk about that. So unit is simply regarded as the measurement of the, it's like you are measuring something predefined. Okay, so you know that this length is actually 15 centimeter. So how do you know? Because this is called 1 centimeter, 1 centimeter, 1 centimeter, and so on. So adding up all those equals to 15 centimeter in 15 times. Okay, so basically mass has unit kg in SI. Now interesting fact is, there is two kind of we normally use, that is SI and there is CGS. Okay, and also there is FPS, but we don't use regularly. So mass and SI unit of kg, and remember SI unit is valid for internationally. So take this as the main features of this unit. Okay, so you understand this CGS, but you don't have to remember all the parts, because we always use these SI units. Okay, so interconversion is allowed if you really want to know about more, but this is the kg, and for CGS it's gram, right? So for length it's meter, and this is centimeter. For time it's simply second, and it's also second. Now here is the three basic fundamental physical quantities, but what about others, like temperature? So if you think about the temperature, it just change, and it's in degree Celsius in CGS, and SI it's Kelvin. okay? It's capital K. Remember this always. So there is a lot of thing we can learn about. So for now, this is all about. So, and what's about the temperature? I will cover temperature in heat series. There I will discuss more details in about the temperature and the heat, okay? And now we will, and the last topic of this discussion will be gravity. So what is gravity? So gravity is simply a force. Okay, so gravity is called a force which pushed by our earth to any object, okay, so that we feel that we are attached to earth. So gravity is simply a force, and there is another term we can mention that it's called gravitational. So gravitational acceleration, right? So gravitational accelerations, so this is simply we represent as it's g, okay, small g. And what is the relation between g? I mean, what is that actually? So g is simply our accelerations, and this acceleration has been produced by gravity, okay? So so gravity is the force that has been produced by the earth. So I will talk, it's a part of general theory of relativity also. So that's a point of view from Einstein. So gravitational acceleration is nothing but a point of discovery of Newton, okay? So Newton discovered there is a gravity. You know all the stories about the apple. So Newton sat under a tree, and suddenly an apple falls from the tree, and then Newton started thinking that why apple always falls in downward, not upward. So there's a meme, I love memes. So there is no one in the sky to eat apples, that's why apple never goes to the sky. That's fun. So but that's not as simple as that. So Newton thought earth has itself a force. So earth has a force which always pulling us towards its center, okay? So that's how gravitational acceleration works. So remember, so that is the force, and this is m. Now this is the part. So this is the force. This force is earth is pulling us, okay? Earth is pulling every object, every single object in the earth, okay? And if the mass of the object is m, and g, it's simply 9.81 meter per second square, okay? So 9.81 meter per second square, that's for g, and m for mass. So here is a beautiful thing, that F equals to mg, which is nothing but comes from ma, right? Where a is replaced by earth accelerations, which is called gravitational accelerations, which is g. So now this force is called, we know it, it's called weight, okay? So this is weight. Now coming to the main point, very important. You never ever thought that there is a difference between mass and weight. So what is mass and what is weight? We always confuse over there. But weight is a force. Remember this as possible as long, okay? Like weight is always is a force, but where mass is simply the amount of matter contained in a body. So like we are made up of atoms, smallest scales atoms. So amount of matter, that means the number of or the mass of the all atoms made the mass. So that means the amount of matter content in our body. But here weight is something different. So the amount of mass, which is m, and amount of gravitational acceleration, where g equals to 9.81 meter per second square, which is traditionally is all over earth, is same. Okay, so you can write down in USA. If you are living in USA, it's always 9.81. Even if you are living in China, or if you're living in Russia, if you're living in India, so it's always about a 9.81 meter per second square. And also this is in SI unit, and also we can write this is in 981 centimeter per second square, right? So this is in CGS. So weight is nothing but force, the force applied on an object by earth. Okay, so this is all about the thing. Now we will talk about the unit of acceleration and retardations and everything like dimensions, which I skipped earlier. Now I will talk about that. So here is the dimensions. So dimension and unit, it's simply very interesting, and also a lot of people are confused over that. That's why I want to focus here. So dimension in unit, simply it's called m. So this is called dimensions when we are putting some capital letter in third bracket, or the so you can call it, and this is L for length and T for time, right? And for unit it called kg. So this is dimension and this is unit, right? And here for length this is meter, this is second. So this is the dimension and this is the unit, and I have written here the SI unit of the mass, length and time respectively. So what was that? So now we have to calculate. So now how to calculate it? So simply, if we want to measure the velocity, the dimension will be simply the distance, which is length. So distance stands for length, right? So distance is nothing but a measurement of length, right? So length over time. So it's, now we will complete the LT minus 1. So if you don't know how this is minus 1 t to the power minus 1, I think you should take I will make a lecture on this. Is a mathematics, pure mathematics. Okay, so I will make a lecture on that. So now just you just concentrate here and just think, this is this minus 1 just coming from the inverse. Okay, so if there is a numerator over there, so numerator will be simply as that, and the lower portions will go there but with a minus 1. So if there is a square, so there will be minus 2, right? So for now that's fine. Now if we want to calculate A, so what is A? Simply we know, so A is nothing but change. So change in V, change in t, and this symbol is called delta. Okay, it's a Greek letter and it's called delta, which represent change. So change in velocity, change in time. So the ratio of that is called accelerations. So we know from there that V is LT minus 1, right? So we simply call that this is LT minus 1, that is for velocity, and T here, right? So we can write down LT minus 1. So this is LT minus 2, right? So for lt minus 1, so t will be go there and it will make lt minus 2 or lt to the power minus 2, right? So that's how you can make the dimensions as easy as possible. Now what's about the mass? So we know A is lt minus 2, right? So what about force? So force equals to mass times accelerations. So we know mass is represented by m and into it's A, which means lt. So we can write down this like this, minus 2. So this is simply m. So or we can write down so mlt minus 2, or we can simply denote it as mlt minus 2, right? So this is how we can measure any type of physical quantities by applying how its derivative or the component or the constituents has been measured earlier. Okay, so this is mlt to the power minus 2. So again, so this is for force. So what about the work done? So work done or energy is similar. So actually this means force into distance, right? So that means force, that is already I have already proved that mlt to the power minus 2 multiplied by L, right? So work done or energy has a dimension of ml square t to the power minus 2. Okay, so ml square t to the power minus 2, right? And this is all about the dimensions. But the complex unit, now I will talk about the complex unit. Obviously that's, so we have already know the unit of mass, the distance and the time. Now what about the complex units? So complex unit means like about velocity. So velocity is simply, we know, d over time. So the unit of d divided by unit of time, so that means its SI will be meter per second, right? So we can write the meter per second. So here we can represent meter per second in this manner, right? So if we change this like A, and then what will happen? So this is also V, so delta V over delta t. So basically delta V has a unit of meter per second, so meter per second, and T for S. So here we can write down this is a square. Okay, so meter per second square. So this is the unit for accelerations. And also if you remember, so earlier I have already written down the dimension of A equals to it's L t to the power minus 2. Now if we write down this in a unit way, so that you know the m stands for length and s square stands for t. Now you can see this is divide, that means we can write down in m is minus 2, right? So you know this is simply as that. Okay, so this is the dimension and this is the unit. All right, now we will check the force. The unit of force is simply as easy as it's simply mass time accelerations. So already we know acceleration is m is minus 2. So here we will write this is mass, so m. Okay, so for it's mass, that means kg, sorry, this is kg. And we know about acceleration, this is called meter, s minus 2, which is, we can write down this in this way, meter kg per second, sorry, per second square, yeah. Okay, so it's called meter kg or kg meter per second square. Okay, so force has a distinct unit in Newton. It's called Newton. Okay, it's called Newton for SI. So Newton represent force as Newton discovered the reason behind the gravity or force. Okay, so Newton is the unit, SI unit of force, which is also equal to meter kg or kg meter per second square. All right, now what about arc? There is a term called arc. Okay, so this is actually CGS unit of force, and there is we will convert this in later. Now for now we'll go for the energy. So what's the energy? Energy is simply energy or work done. It's simply force multiplied by distance. So if force multiplied by distance, then obviously we know that it's already called meter kg per second square multiplied by meter, right? So distance is meter, so it's the force, it's the distance. So what will there? It's meter square. So this is, we can call kg meter square per second square. So it's called kg meter square per second square, right? And also energy has similar a single unit for CGS and SI, which is for SI it's called joule, which is represented by capital J. Okay, and there is okay, so it's called arc. It's arc. So arc is ARG. Okay, or it's called arc. Now I have written a error here. So force, the unit of force is simply Newton for SI and dyne for CGS, right? Actually dyne and arc is not popular since it's not used for many years. Okay, so we don't use dyne or arc normally. So dyne, I have an error. So this is the unit of force. It's called dyne and it's CGS for CGS. Now we will take about to convert this unit like SI to CGS. So how to convert that, I will go with it. Okay, so here so convert. So unit conversion is one of the major part of mathematical physics. So mathematical physics is a long and broad way. So unit conversions is simply unit conversions. So we are about to convert unit from SI to CGS and vice versa. So you know 1 meter equals to 100 centimeter. Okay, and 1 centimeter equals to 0.01 meter, or you can write down this is as 10 to the minus 2 meter. So this is the unit conversions for the length. For the kg, it's called 1 kg equals to 1000 gram, or 1 gram equals to 10 to the power minus 3 kg, right? So 1 kg equals to 1000 gram, or 10 to the minus 3 kg equals to 1 gram. And also there is time, which is same for both SI and CGS, so we don't have to convert it. Now we know about velocity. So velocity is simply meter per second. So if we want to convert meter per second to centimeter per second, it simply will be multiplied by 100 to convert into meter to centimeter, right? So centimeter per second and will be multiplied. So if we just multiply this answer with 100, we will get that. Okay, so suppose there is 4 meter, so 4 meter per second, so we will multiply this and we will get 400 centimeter per second. So if we want to convert meter per second into kilometer per hour, which is a very standard way to measure the velocity or the speed of a vehicle, so meter per second converting into the kilometer per hour, so we know that 1 meter, so basically we are about to see, so 1 meter it's called, so we can write in this way if you don't know about, so I will not make it complicated for the beginners. So what does it mean? So it means in 1 second, it's 1 second, the car is moving, suppose 4 meter. Okay, so in 1 second it's moving just 4 meter. So here you can see this is hour, so 1 hour, so 1 hour equals to 3600 second by 16 to 60, so 3600 seconds, so it will be multiplied by 3600 into 4 meter, right? So now you can see if we multiply this and then, so this 1 second, so 3600 into 4, now I want to convert meter into kilometer, so that I have to divide by 1000, so that I can get kilometer per hour result. So here it's simply, okay, so 4, it's 2, it's 5, so now you can calculate it and you can write down the answer. Okay, so whatever the answer will be, it will be converted into kilometer per hour. Okay, so that's the value in kilometer per hour. So now we will talk about the unit conversion of the force and the energy. So we know the unit of force in SI is 1 Newton, and we want to convert in the dyne, which is CGS unit of force. Okay, so 1 Newton equals to actually this is 10 to the 5 dyne, and also, so how do you know that? So 1 Newton, so what is 1 Newton actually? So 1 Newton equals to 1, it's 1 kg, and 1 kg, it's force into distance, so meter per second square. Okay, kg meter per second square. So what does it mean? It simply means if we take a body or object has a mass of 1 kg, and if we push hard, so that its acceleration will be 1 meter per second square. So the, you know, what does it mean by 1 meter per second square? It means per second the velocity will be changed 1 meter per second. Like if the initial velocity is 4 meter per second initially, and after applying a force from myself, the object final velocity will reach to the 6 meter per second. So the velocity change is here 2 meter per second. Okay, so the accelerations will be 2, which is 6 minus 4, so 2 in 1 second, so 2 meter per second square. Okay, but what about the 1 meter per second square? That means 4 to 5. Suppose the final velocity is 5 meter per second square, so the velocity is changing from 4 meter per second square to 5 meter per second, 4 meter per second to 5 meter per second in 1 second. So we can calculate the accelerations and we will get the result as simply as that. It will be 1 meter per second square. That is how we can physically interpret the accelerations. All right, now what about the Newton and what about the 1 kg meter square. So if the object, now what I have done, that the changing the speed by applying a force. Now if the object has a mass of 1 kg and the acceleration is 1 meter per second square, then it's 1 into 1, which is 1 kg meter per second square, and that is 1 Newton force. Okay, so 1 Newton force is simply means 1 kg meter per second square. So now I want to just convert this kg and meter into the CGS unit, right? So you know it's 1 kg, so it's simply kg. So kg means 10 to the power 3 gram. Okay, so 10 to the power 3 gram into meter, which is 10 to the power 2 centimeter per second square. Since second will not be converted into second, so I don't require to convert it. So here you know that 10 to the 3 multiplied by 10 to the 2, which is 10 to the power 5 gram centimeter per second square. Okay, so this is 1 Newton. All right, so you can see this gram centimeter per second square is actually unit of dyne. So we can replace this gram centimeter per second square with dyne. So we will get the 1 Newton equals to 10 to the power 5 dyne. Now for the last part of the unit of energy conversions will be as same as follows. So already we know the unit of energy or work done is joule. So 1 joule equals to is about 10 to the power 7 arc, right? So how do you get that? So 1 joule equals to simply force into distance. So simply you can remember this as 1 kg meter per second square. It's simply as force multiplied by distance, so it's meter square, right? So 1 kg meter square per second square. So we will convert it into, so kg will be converted into gram and meter will be converted into centimeter. So here it means kg, which is 10 to the power 3 gram multiplied by meter square, that means 1 meter into 1 meter, which is 10 to the power 2 into 10 to the power 2, and it will be centimeter square, right? So it will be 10 to the power 7 gram centimeter square per second square. So that's how we can measure the and we actually measure and the convert into SI and CGS vice versa. Okay, so this is the all the thing I have already interpreted with the thing like physical interpretations. Okay, so now for the temperature there is unit conversions of like that. So temperature has also unit conversions. So for Kelvin to Celsius, and there is also Fahrenheit. So Fahrenheit, Celsius, and actually degree Celsius and degree Fahrenheit, and Kelvin there is no degree. Remember, there is no degree. Okay, so it's Kelvin or 0 Kelvin, 273 degrees Celsius, and sorry, minus 273 degrees Celsius and Fahrenheit. So here is a catch. It's actually the relation is 0 Kelvin equals to minus 273 degrees Celsius. So why this is minus 273 degrees Celsius? Okay, so for now you know that temperature I will cover in this in the later videos, but for now you can understand that is in the 0 Kelvin or minus 273 degrees Celsius is the ultimate minimum temperature possible in the universe, because before 0 Kelvin or minus Kelvin, it's impossible to have a positive volume. So minimum volume will be 0, which is 0. Okay, so that is actually achieved by in a temperature of 0 Kelvin, which is actually minus 273 degrees Celsius. So it's simply we can, so if there is C, so C plus 273, okay, which is K. So this is the relations between Celsius scale and Kelvin scale. So if the temperature C equals to minus 273, so minus plus it will be 0 Kelvin. Okay, and the relation between Celsius and Fahrenheit is as follows. It's simply C by 5 equals to F minus 32 divided by 9. So C by 5 equals to F minus 32 divided by 9, which is achieved by in this following explanations. So suppose there is a two scale, and one scale defines this is C and this is F, right? So the minimum is here. Okay, so for the centigrade scale or Celsius scale, it's the minimum is 0, where if the Fahrenheit scale has a minimum of 32 degree Fahrenheit, which represent the melting point of ice, okay, and the boiling point of water, which is the ultimate point, which is 100 degrees Celsius for Celsius scale, and Fahrenheit it is 212 degrees Fahrenheit. So 212 degree Fahrenheit for Fahrenheit and 100 degrees Celsius for Celsius scale. So now what will happen if we take any Celsius scale, the temperature from Celsius scale, and consider this is as C, and then we just subtract from the minimum value, which is 0, okay, divided by the divisions, like lot of divisions are here. So the divisions we will divide here, so which will be 100. So actually you can see there is 100 divisions over there, so it's simply as that. And here also we are comparing it with Fahrenheit, which is F minus 32, which is minimum point, and divided by 180, which is actually 212 minus 32. So this is the maximum and this is the minimum, which is 180 degree. So there is a 180 divisions over there, okay, and then we can compare this and we will get C by 100 equals to F minus 32 by 180. By simplifications we will get, so by simplification we will get C by 5 equals to F minus 32 divided by 9. Okay, so that's how we can remember this formula for the temperature scales conversions. And this is all about the conversion of unit. So in the following video lecture I will explain more topics in very quick, just because my intention is for the physics major students. Obviously I teach physics major and also mathematics for the fans. If you really like this video, give a thumbs up, which will in YouTube algorithm, if you like a video, so this video will automatically by algorithm they will get more views, which will in return will help me to produce more videos like this. So, and more importantly, I have a mistake over there because I am really nervous, because I am an offline teacher, I am a PhD scholar, but I really don't I actually never use online teaching like before. That's why I'm really a bit of nervous. So I will improve myself with these video lectures, and also I will explain a very nice topics like why sky is blue, why red flower is red or black in the nights. So there is a lot of answer and there's a lot of questions, so I will explain it in very easy way, so that a lot of people, even from not from the science background, can understand those questions. Okay, so for now this is it. Okay, thanks and have a great day. And fellow mathematicians and the fellow physicists, please subscribe my channel so that I can grow.